Good morning, everyone. Welcome to the next practical on QGIS. In this practical, we will learn to write an algorithm to perform a certain operation on a given data set. In this, I am taking an objective as identifying an important towns in Maharashtra and finding out where to place a COVID center so that no patient has to travel more than 100 kilometers. So that even in remote places, we set up COVID centers. For this, the input data, I'll be taking the KML files which we have made in Google Earth in the last practical. So I'll just add those files. So go to add layer, add vector, and add the boundary, Maharashtra boundary. It is on my desktop. And another one that we have made that day was places in Maharashtra. So I'll just identify the places in Maharashtra, and these two are my KML files. Now, after adding this, the first thing that we have to do before we proceed to making a model is convert these KML files into the SHP files. The reason for it, I'll tell you that. Suppose I take this file and go to the vector operation, say a buffer. Now, what do you see is the distance is in degrees. This is because in KML, the CRS that is there is not as per the requirement for which we have to perform various operations. Similar problem we will face when we are using selecting the places in Maharashtra. So that also you can see it is in degree. Now to remove this problem, it is important to convert this KML file to the SHP file. The another problem that you may experience is when I use the scale, measure a line, say I have to measure a distance between these 2 points. So as you can see, it is only 11 kilometers. So this is not a correct distance. So this CRS is also not giving us the correct distance. So what we have to do is we need to just convert this to SHP file. That's a simple step. Go to export, right click, go to export, save feature as. So this is my boundary of Maharashtra, and CRS I'll be taking EPSG 3857 WGS84 pseudo Mercator, and simply no resizing, nothing. I'll simply press it as OK. Similar same thing I'll perform with the places in Maharashtra. Right click, go to export, save feature as. I'll just name it as point. Again change my CRS to WGS84 EPSG 3857 and press OK. Now I can just check whether the two shape files are correct or not by just going to vector and buffer. Just see, your degrees has been converted to meters. So we are successful in converting to shape files. So I'll just remove the KML files from my project by right click and remove the layer. After removing this, now we will go to making our model, that is an algorithm. For that, go to processing, graphical modeler. In this, there are two in parts. One is the input and the other is the algorithm. So for us, in this case, the input is a vector. So I'll just go to a vector layer, just take it here, give it a description as input. Geometry, it can be any geometry or point specific for this particular case. If I say any geometry, the input could be a boundary or a polygon, and press OK. So my input has come. Now the next thing that I want to perform, since I have to find out the overlaps and the distances within 100 kilometers so that no patient has to travel more than 100 kilometers, I need to just draw a buffer around my towns that have been identified. That buffer comes in the algorithm. I can simply search it by the name So buffer is here. I'll just take it. It asks me for an input. The input has to be not a specific value, but any value. For that, we'll make it as model input. Now distance, this is in meters, so I'll just need to convert it into kilometers. Okay, so 100,000 meters is 100 kilometers. This segment defines as how many segments are required to complete one circle. I'll just take it as 25. I will not dissolve the boundary so that I should be able to see the boundaries of the buffer. And whenever your algorithm is giving you the final output, in this we need to give it any name so that it knows that this is the end of the algorithm. Right now we are writing just a simple algorithm. So I'll just say okay. So this completes my algorithm. And now what I have to do is I have to run it. So run this model. Now in this I have to give an input, so it will ask input as what it is. So I have named a point. In case there are many, it will give you a list from which you can select this point. So depending upon what all you open in your QGIS window, this may have the various options. This right now I'm keeping it as temporary, and I'll just run it and close it and go back to my QGIS window. You can simply see I have not done anything here. Just by running that model, my output is displayed on my QGIS. Now what was our task was to find out a layer, create a layer. So I'll just go to create layer, create a new shape file, and it will be hospital locations, and it is a point file. I'll just say okay. Take my toggle editing tool, points. So from here to here, it's a distance of 100 kilometers. So first hospital, I'll place it here. The second hospital, for here also it is 100 kilometer. I'll just push it. For people here also it is 100 kilometers. So I have an option of pushing it here, so that people, I can just take a scale to measure the distance and escape. Um, we can just see the window of segments as where it will be 100 kilometers. So from this boundary, it is somewhere here. So I'll just escape or toggle editing tool. So somewhere here as per this. So it is my hospital number 2. Okay. And then I can again find out where I should be placing my third, maybe somewhere here, so that everyone, less number of hospitals are required, so less facilities. And again from here, somewhere here will be, I can measure the distance and place it, and here at the center. So I have 5 hospitals. I have 5 hospitals for 6 districts. So that is how we take a decision to place the right location of the hospital, or many other decisions we can take. The same thing can be used for identifying the right location to take a flat. In case I want to see that the school is near, a shopping market is near, and a hospital is near, eateries are near. So I can just have a clear picture of all these locations and take a decision depending upon what will be the right location to purchase the flat, or identify a location where I should be having a flat. So this will reduce our task of actually doing one operation, but help us to do multiple operations at one time using this algorithm and model builder. Now we are doing the second part of this practical where we have multiple inputs and then we take a decision. For convenience, I have already inputted the three files that I have taken or made from Google Earth regarding some schools in Gurgaon, available flat locations, and the hospital locations. Practical. This practical, in this practical, what I have already done for you is I have made the input files regarding some schools in Gurgaon, available flat locations in Gurgaon, and the hospitals. So depending upon the nearness of the schools and hospital, we can take a decision as which will be the best location for renting a flat or purchasing a flat, so that the essentials like schools and hospitals, we can add more inputs and take a decision. I'm just inputting three files and making a decision as per that. So these are my files. As I told you in my first video, we first need to convert these files into our shape files. So it is school, and I have to select EPSG 3857 and press OK. So my flat is, then I will make for flats. Again changing the CRS, and the third one is hospital, which again I'll convert and convert our CRS. So now I will check whether the files that we have made is correct or not by just going on vector and using buffer to check whether the units are correct. So yes, our units of length are in meters. So our conversion is done. Now I'll remove the KML file by deleting these files, flats, and the schools. Now I'll just build my model. So we'll go to the processing graphical modeler. So first I have three inputs. I'll take the vector layer 1. So it is input 1 and its geometry is point, and OK. Then input 2 is again a point and press OK. Then again I have a third input. Again I'll make the geometry point. OK, OK. Now what I have to do is I have to build a buffer around each and find out the interference point. So I'll just type buffer to find out the vector. So buffer for each input. So it is buffer 1 for, and again as I told you, the input will be a model input and it will be input 1. I just want to make it 10 kilometers, within 10 kilometers, or even I can make it as within. And as I told you, the segments I can take 20, 25 to make a perfect circle. I'll not dissolve the limits as I said, and this is not my final output. So I'll just press OK. So as you can see, directly connected. One more buffer I need for input 2. I name it as buffer 2. Again, make it as a model input, and this time the input is in. Now again, I'll do it for the third input, a buffer with the name buffer 3, and the input is a model input, and the input this time is input 3. $25. Okay. Now this will add a buffer. Now what do I want to see is the flats which are near to the school as well as to the hospital. So I want to find out the interference. So again, intersection, as we can see, there is an intersection. So for this intersection, what is my input 1? So I want the input 1 to be a model input 1, and the overlay layer will be again, sorry, it will be a algorithm output. So it will be buffer 1, and the overlay layer will be again an algorithm output, which will be from buffer 2. And then anything else we need to, since this is not the last, I'll say okay. So I can see the output from the two buffers are getting intersection. I need one more intersection, which is uh, intersection 2, which is nothing but input layer is algorithm output, which is nothing but buffer 3, and the overlay layer is again an algorithm, and this time it is intersection, because I want to see the intersection of, and I also know that this will be the last. So I'll just go and make this entry as final, so that this is an final output that I'll be seeing. So this is an algorithm where I'm taking a decision based on 3 inputs and some analysis that I'm doing. Let's see whether we get the output or not. Now I have used different symbols for flat, school and the hospital. Now I'll apply my model builder, that design that I have made, in which I'm giving the 3 inputs. Input 1 will be a school, 2 will be a flat, and 3 will be a hospital. I'm building a buffer of 2 kilometers around each point, that is a flat, school, or a hospital, and then finding the intersection of a flat and the school and flat and the hospital, and finally finding the intersection between these 2 points, so that I get a flat location which is having within 2 kilometers a hospital and a school, which are essential while deciding any location. I've simply added the sub 1 and sub 2 to have input about what I'm getting at these points, so that I can find out what is happening at this point and this point. And that is why, and the final will give me the final output. Once we have the output, we can remove these two. We can remove this for to see if we can actually see the output without them also. So first let us run it and see. So I just run it. I've selected input 1 as school, 2 as flat, and 3 as hospital. These 3 are the temporary files. I simply run it and then close it and go to my QGIS window. So as you can see, these are my sub 1, sub 2, and the final output that I'm getting. What I'll do is simply shift the hospital up so that it is also visible in my output. So you can see, and let me uncheck sub 1 and sub 2, and this is the final output which I'm looking. So it is around the flat. This is a flat which does not have a hospital and a school within the 2 kilometer, but this is the flat location where it has hospital and the school within the 2 kilometer range of intersection, and therefore with respect to other location, this would be the most preferred where you have the essential of school and hospital name. So you can simply tag it, or you can identify it and take a decision as best location for your residence or flat purchase. Thank you.